So today we're going to start a whole lesson on conic sections, what the conic sections are, and specifically today parabolas. So the big thing here is if we have a cone, and I'm going to draw a cone that looks like this, kind of like an hourglass. If we intersect this cone parallel to the base, we're going to get a circle. That's one conic section. If we intersect the cone parallel to the edge of the cone, then we're going to get another conic section called a parabola. If we intersect the cone not parallel to the base, but it goes through, then we get an ellipse, kind of like this figure here is an ellipse. And if it's perpendicular to the base, then it's going to intersect both of these parts of the cones and be a hyperbola. And so we have three conic sections. They are a parabola, a circle, an ellipse, and a hyperbola. And today we're going to be focusing on parabolas. So let's start with the definition of a parabola. A parabola is a set of points in a plane that are equidistant from a fixed line and a point. So the fixed line we call the directrix, and the point we call a focus. So if we have the focus here and the directrix, which is the line, all of the points that are the same distance from the point as they are to the line make up a parabola. So for example, we have one point right here that's the same distance from the point as it is, the focus as it is from the directrix, but then there's another point right here where this distance is equal to this distance. We have another point about right here where this distance equals that distance. Maybe there's another point up here where this distance equals that distance. And if we kind of went all the way to the right and all the way to the left, we would end up with a shape that you guys know, which is a parabola. So suppose we have a point which is at the point 0, 3. So let's say this focus is at the point 0, 3. And the directrix is at y equals -3. So we have something that looks like this. Here's the origin. So we have -1, 2, 3 this way, and then we're going up 3 here. And so we want to find all of the points that are going to make up this parabola. Well, we want to find, if this is a point xy, we want to find all of the points xy where this distance here is the same as this distance here. And so one of the things to help us with this is we're going to need to know the distance formula, which really comes from the Pythagorean theorem. So we're going to find the distance between those points. We're going to call this point here xy. And this point we know right here is it's still over x because that x matches that x, but it's at -3. And so if I plug these values, we have 3 points, xy, and 0, 3, and the point x -3. And we want these two distances to be equal. So we can first find the distance to the point 0, 3, which is this distance here. And so I'm going to take my x minus 0 squared plus the y minus 3 squared. And this value right here gives me this distance. But I want that to be equal to the other distance, which is the distance from the point on the parabola to the directrix. And so I'm going to take the square root of x minus x and then y minus -3, which would be y plus 3 squared. And that gives me this equation. Well, if we clean this up, if I square both sides, x minus 0 is just x, so that's x squared. I still have the y minus 3 squared. But if I square both sides, then both square roots disappear. Also here, I have x minus x, which is 0, so that just disappears, so I have the y plus 3 squared. Well, if I square both of those, here I have my x squared, and then if I take y minus 3 and square it, I'll have the y squared minus 6y plus 9. And if I take on the other side of the equation the y plus 3 and I square that, I'll have y squared plus 6y plus 9. Well, then there's some things that I could simplify. So for example, my y squareds can cancel out, my 9s can cancel out, and I can add 6y to both sides. So if I added 6y here, they would cancel, and if I added 6y here, I would end up with x on the left and 12y on the right. Well, then I want to solve that for y. So I'm going to divide both sides by 12 or multiply by the reciprocal of 12, which is 1/12. And so x or y equals x squared over 12, which is the same thing as 1/12 x squared. This is in this form, y equals a times x squared. So the a is 1/12. Well, there's something special about that 1/12, and that's this relationship. The absolute value of the a value in a general quadratic equation is equal to 1 over 4 times c. And c is the distance from the focus to both the directrix, or from the focus to the vertex and the directrix to the vertex. In other words, this value right here is has a distance of 3, and this value here has a distance of 3. And we know that our a value is 1 over 12. Well, if that equals 1 over 4 times c, we know that c has to be 3. And so I really could have found this equation of the parabola without going through all of that step. I could have just realized, well, it opens up, so the a value is positive. I know that my c value is 3, so I could take 1 over 4 times 3, which is 1 over 12, and x squared. And that would have been my equation. And I could have done it that easily without going through this mess. And so let's take a look at how these shapes of these parabolas are affected by the a value. For example, if I have a general equation like this, I have an a value that opens up. I will have the focus in the middle, and the directrix will be below the vertex. It's kind of like a pea in a bowl on a table. Okay, so I have a pea in a bowl on a table. And it opens up. Now, if the a value happens to be negative, then everything gets flipped around. So it's going to look something like this. I'll have my parabola here, but the focus is below it and the vertex is above it. So I have parabolas that open upside down if the a value is negative. Now, something we haven't talked about yet is what would happen if we switch the x and the y around. So instead of y equals x squared, we have x equals y squared. Well, we're still going to have a parabola, but instead of opening up, this is going to open to the right. And we're going to have the focus to the right of the vertex and then the directrix to the left. And this is, the a value is positive, which means the parabola is opening up in the positive direction. But instead of in the positive y direction like it is up here, it's in the positive x direction. Our last situation would be if the a value is negative and the x and the y are switched. Because in that situation, the parabola is going to open to the left, which means the focus is going to be to the left of the vertex and the directrix is going to be to the right. Now, one interesting thing is these bottom two are not functions. They don't pass the vertical line test. So it's not like we can graph these on our graphing calculator. We know that on our graphing calculator we got to get the y by itself in order for it to be a function. So we have to graph these more by hand or by knowing what the shortcuts are. So how does that play a role in finding the equations of parabolas? Well, let's take a look at this example. We want to write an equation of a parabola with a directrix at x equals 4. So that's this line right here. There's my directrix. And a vertex at 0, 0. Here's my vertex, which means I know the parabola is opening in this direction. I also know that the focus is at the point negative 4, 0, because the c value, which is 4, also matches this, which is also the c value. So I know it's going to be in this form. It's going to be where we have x and we have a y squared. I know that the a value is going to be negative because it opens to the left. I know that the c value is 4, so that means 1 over 4 times c is 1 over 4 times 4, which is 1 over 16. So the equation for this particular parabola is x equals negative 1/16 times y squared. Let's take a look at another situation. What is the focus and the directrix of this parabola? Well, first of all, we have a normal parabola that either opens up or down because it starts with a y. I also know that it opens down because the a value is negative. And so I'm going to have a parabola that looks something like this. It's going to be opening down. Well, then I want to figure out what the C value is. So I know the absolute value of A is 1/16. That equals 1 over 4 times C. And so that means that 16 equals 4C. And if I divide both sides here by 4, that C is 4. So that means from the vertex, if I count 1, 2, 3, 4 units down, my focus is at the point -4, 0. And if I count 4 units up, my directrix is that line at y equals 4. And so what is the focus? -4, 0, and the directrix is at y equals 4. All right, so let's take a look at what else is happening here with parabolas. First of all, let's go back and review about how these parabolas are shifted. And so I'm going to pause this video and start another video on shifting the parabolas. And so that'll be video number 2.